presentation of sustainable dock lighting. And we'll start with the abstract. Our objective, I'm going to read this a little bit word for word. The objective of this design is to have a barrel that utilizes solar and wave energy through a solar panel and a linear generator to create electrical energy that can be stored into two batteries and power a light system that will turn on during the night and by dawn. The buoy design includes an air gas barrel or a 55-gallon barrel drum with a solar panel and a red LED warning light positioned on the lid, a horizontal linear generator position in the upper portion of the barrel, above a free surface pipe to exaggerate the swing movement of the barrel, and charging components and two deep cycle batteries positioned on the bottom of the barrel underneath the false line.
Alright, so we have problem statements for both sections of clients that we are trying to target. So for our public docks, we are trying to create a light that is completely independent from our power grid, so that if a power outage occurs, at base case scenario, the operations can continue, and at worst case scenario, the operations can at least come to a safe halt, and they're not plunged into total darkness. For our private docks, we have a light that is able to light up a dock that could be anywhere, so your lake houses, your bay houses. These can be your remote locations, like I said, or where power is too expensive to tie into, and this is a safe power supply to have near the water. So for our client need, like I said, we have our public docks and our private docks. So for this, we have a sustainable lighting for our public and private docks. Lighting independent of our power grid, so we're not hooked up in any way, shape, or form to our common power grid. This lighting is provided by two sources of renewable energy. We have our solar energy and our wave energy, like Austin said. And it is what we strive for it to be, was a cost-efficient, do-it-yourself type system. So our goals and objectives for this project, we have lighting independent of the power grid. We are providing at least 400 lumens of light. Our light strip that you'll see later on covers this requirement. Our lights turn on at dusk and turn off at dawn. So these lights are mainly for nighttime operations or a nighttime dock situation. We have a red warning light that is on at all times as long as this thing is in the water and our electrical stuff is hooked up correctly. We are completely waterproof, and we have completely insulated batteries compared to the rest of the barrel, which there's a false floor that you'll see later in this presentation, where the batteries are completely underneath that floor. So for our actual specifications, we have our 55-gallon plastic barrel, which is the air gas barrel that Austin mentioned. We have our two deep cycle batteries that are rated for 12 volts and 9 amp hours. We have one 50-watt 12-volt solar charge panel that sits on top of our barrel. We have our LED tape lighting, which the entire lighting output for that strip of lighting is 1200 lumens. We have a horizontal linear generator with our free surface effect pipe. They work together. Then we have our charging components, which is all of our electrical, and then obviously our two pieces of anchor, our rope, and our cinder blocks.
Standards and constraints. The only standard that we have here would be coming from the Coast Guard, which research barrels and buoys are considered as private aids navigation, and private aids navigation must be able to be lit during nighttime and be visible for 1 nautical mile. And if it's not running off of shore power, it must be able to sustain itself for 10 days without any maintenance. And that's it for this. Our schedule, we all started planning everything during the fall semester, and as soon as we started getting this project up and working, we had a lot of new ideas coming in. All right, and so our finish date with the completion of the planning phase was around midway for the spring semester. And so when we started our construction phase, we had a planned completion of early April, but we didn't finish until halfway of April because parts were coming delayed, and we had some construction restraints. Every now and then we get backed up. And during the prototype phase, we finished where we wanted to, which was the 22nd of April. And the reason why we stopped like yesterday, last morning, was because we wanted to make sure that there was no faults and no problems with this system before we actually presented this presentation. Here's take a look at our gang chart. We got a, this is, the last time this was edited was around halfway of April. And the reason why is because coming back to this, it was around the construction phase, it was like going to a confessional. That's why I got like a red line right here. It was to show that we kind of went over time and, you know, like coming back and not meeting the days that we were supposed to. So this line represents our actual finish phase of finish of the construction phase. And we had about 2 days to actually do testing. And once we were done, you know, we actually made it.
So, our analysis for decision making, we went through several iterations on our design, and originally we were going to have stuff to be mounted on the T-dock, and then later we found out that we weren't allowed to have anything on the actual dock for risk for the university. So we had to make some changes and put everything on the buoy and make it self-sustained. With that, we had some wasted resources, and like it was a little different with the tweaking we had to make for our final design, but ultimately we were able to make 2 power sources on our barrel and batteries and power storage. That's what I was here for. So task mapping, we have our tasks assigned up into several areas where people excel in what they can do. Scott was the main man for our generator, and and everyone's tasks were assigned relatively to their strengths. This is just what we're here to show what everyone did.
Our bill of materials and final cost. We this is the lineup of everything, whether and according to each system. Our linear generator costs about $90. Solar generator about $115, though I will make an adjustment later. Lighting and batteries and wiring about $150. Our barrel and other miscellaneous items about $130. And our starting budget was from the school was $500, and we spent almost all of it. And but I also wrote down a total effectiveness about $400. And the reason why is because this was due to some of the objects and items that we decided to replace because they were not coming to the standards that we wanted to. For example, for the solar generator, we were thinking about getting 4 or 6 small solar panels, but we decided to can that and replace it with a 50 watt, which does the job for twice the amount of job in half the amount of money, which the pattern follows with some of these other things with the barrel miscellaneous items, like such as the Whirly Bird. Excuse me. First, we had to start planning everything with the electrical plan. We had to start off with the demand, which is the warning light and the LED strip. At some point, we ended up cutting the LED strip in half in order to reduce power consumption, and we kind of went off of that. We made an adjustment with how many batteries we had. We started with 1, now we're with 2, and now we have a 50 watt solar panel, which we compared with the 4 smaller ones, Sunny Techs, and right, it's about actually 4 times more than 4 times that, about 4 times the power. And we also had to take a look at what time the sun is out and what time the sun is not out, because it was important to make sure that we have a sufficient amount of time for when the buoy is lit, as well as the buoy getting charged by the solar panel. And this is our visual of the electrical diagram. This is not in like any kind of electrical works program, but this is just for someone to visualize what we needed. This is the linear generator right here, represented by the inductor. It needed a rectifier because the way how we made the generator is that it will produce AC, and so we had to turn that into a DC source. We had to make a rectifier. Our solar panel, that panel was represented, and same thing with the batteries, the photoresistor LED strip, and 555 timer, which is already included in the warning light that blinks, and 2 batteries, both 9 amp hours, so a combination of 18 amp hour, and our solar charger controller to make sure that everything is safe. It warns us if there's a short or if in the different stages of battery charging.
Okay, here's how we started our construction. We had to start by figuring out where we would test it. We chose the T-Dock because it was readily accessible and we had permission to use it. And then our first thing we had to construct was the generator. So we used a lathe to turn and wrap the wire around it. Still took a long time because there was over 1,000 wraps around it, but it made it the easiest way to do it. And once we got that done being wrapped, we covered it in a varnish to protect the insulation and make sure that we wouldn't have any shorts of ground accidentally come from wear and tear. Then we had to prep our barrel for inserting all the components. We drilled holes in the side of it for the free surface pipe and the linear generator to be inserted. And then we cut out for our false floor to be inserted in the bottom, and we put brackets for our batteries, and then put Velcro straps over them to make sure the batteries don't move around while it's in the water. We had to make a wiring circuit to control when the lights came on, so we had to construct that from scratch and test it to make sure it functioned, and then we had to install our lights along the edge of the barrel and on the lid, and then we had to install our lid. Finally, we had to complete the project by making sure everything functioned, everything fit correctly. When we put it in the water, we found out that it wasn't quite as stable as we wanted it to be, so we had to put sand in the bottom to give it a little more stability, and then once that was done, we had a fully functioning thing and all of those testing. And then moving on to testing, we had some pre-tests before the final. We tested a whirlybird to see if we could use it for our generator. It failed. We had to test our linear generator to make sure that it had voltage pass through it, so that we knew there wasn't any thing messed up with the coils, and make sure it generated power. We had to test our solar panel to make sure it had the power output we wanted it to. And then this is from when we tested our linear generator. It was installed inside the barrel. We basically just took it up there, shook it around, got the magnet to move, and we could consistently get about 2 volts for each pass with the magnet. And then we took it to the water for our first test, which, like I said earlier, ended up, it was not as stable as we wanted it to be, so we had to put more ballast in it.
So these 2 videos are our first 2 tests. This test on the left was the second test we had. It was the first one with everything in it. It was swaying a lot more than we wanted it to, and so that's when we decided to add some more sand to the bottom to lower the center of gravity and increase our buoyancy. So the second video is that our final test. This was the one we let it go all overnight, and our lights turned on how we wanted them to, and they turned off promptly in the morning. We stayed up all night watching it and making sure it didn't float away. So we all, like I said, we all took shifts overnight, about 2 hours each. The lights, they came on at 8:09 at night, and they turned off at 6:25 in the morning. The warning light continued to function after that point, and so it was at that point that we took it out of the water and concluded our testing.
This is our risk assessment. We ended up trying to understand the how problematic some of these incoming risks were by multiplying the severity and the probability in order to get a value. And we have our list of mitigations for each of these. If we're behind schedule, we ended up working a lot more. Our linear generator concepts failing repeatedly. We had to keep changing our concepts of linear generation or any type of generation. We ended up starting with a plunger type, and then we ended up getting to a omnidirectional turbine type, and then afterwards we ended up sticking with this one, this wave generator that rocks back and forth. And solar panels now we're creating the required energy. We talked about the Sunnytech small solar panels. We ended up canning those and ended up replacing it with the 50 watts solar panels, and the barrel wanting to roll over. We ended up taking some time with putting in the right amount of ballast, as well as during the testing phase, making sure that we had shifts all throughout the night while we were field testing this.
Alright, so some of our achievements and failures we covered already. So obviously, like we said, the whirlybird, it did not work. So we had to scrap that idea. Our linear generator, it did work. That was a big achievement of wrapping the wire like that. We did have a breakage in one of the wires that we had to resolder back together to continue to wrap it. So we were pleased with that. These are the Sunnytech generator, or the Sunnytech solar panels that Austin talked about. They were not sufficient on what we needed. And then our big 50-watt panel is what we ended up going with. It did pass our expectations. So, and then obviously our achievement is our lights working. So this video is kind of quick. You can see that the lights came on and off with the hand over the top of our photoresistor, and then our LED light working at all times with no help. So an obvious achievement is that it floated. We didn't have water in the barrel when we put it in for the first time, and while it did float, it did not float away. I did have a hold on it during these tests. And then our final achievement was our lights working. So we did Wednesday night through Thursday morning. Our lights came on at 8:09 to 8:10-ish, so that's the photo of it fully on at 8:10. And then our shut off was at 6:25, our total time lit 10 hours, just over 10 hours.
Okay, so our team member contributions, our team lead is Austin Chudowski. He did communication with our advisor, created baseline for reports, soldered electronics, and he was our schedule and budget manager. Emily created our weekly progress reports. She did the main communication with our advisor. She assisted with construction of false floor trapdoors and other things. She assisted Albers with testing our electronics, and she was our main person in water testing. Albers was our linear generator lead. He did all of our electronic component combinations. He assisted with the installation and construction, and he was our component testing lead. Nolan Peterson was our main construction person. He assisted with in-water testing. He assisted with creating all presentations, and he was the barrel lead. And then myself, I was the solar power lead. I assisted in component testing and electronic combination with Albers. I made 3D models in SolidWorks and printed them with my 3D printer, and I helped with construction as well.
So we have some recommendations for this project. The plastic barrel was a little, at times, unforgiving to work with as a material, because I'm not very skilled with plastic. There's a lot of dremeling, a lot of JB Weld involved. The metal barrel, however, that was what we were leaning towards in the beginning. This would have had a lot more convenience for just being easy to work with, because you can always add more steel to it. And then for the ballasting as well, you could add weights to the bottom of it. With the plastic barrel, I couldn't exactly weld anything to that, so we had to add sand at the bottom of it. And then putting the solar panel on the dock would have been a lot more forgiving for this project, because it would have taken away the top heaviness of the barrel, because it was rolling all over the place when we put it in for the first time.
Is there any questions for us?